80% of the world's electric, kinetic, and any other energies are created by burning fossil fuel. Today's state-of-the-art technology operate with a non-efficient single-cycle burning process that is based on a principle of more than 100 years ago. The Reinhardt turbine adapts this single-cycle principle with an integrated machine based on 3 combined cycles to double the efficiency of diesel, Otto, or any other combustible engines easily throughout a piston-driven turbine. We show here a standard Otto one-cylinder motor. Its heat and pressure is created by an explosion caused by pressure within a closed chamber combined with an electric spark plug. This process is used in principle in all combustion processes. With diesel engines, the electric plug can be omitted due to higher compressions and self-explosions. The extent of heat created by the explosion is demonstrated by the intensity of red color, whereas when the heat is quickly lost is demonstrated by the quick change of color into yellow. Within a second, in most common processes, combustion takes place within an open chamber or kettle by permanent burning of fossil fuel. In this case, the heat is converted into steam, which can be transferred into an expansion chamber of a steam engine, illustrated on the right. The explosion rooms are quite similar to the ones of the Otto engines on the left. The externally created steam is injected into the steam cylinder, where it expands by losing its high temperature. Both processes have each on their own only got a maximal efficiency of 40%. This means that 60% of the heat which is created throughout the combustion is lost. We would like to show you that it's possible to increase the efficiency of 40% of up to 60% efficiency, and in the future reach even up to 80% efficiency without the necessity of extraordinary parts. Only the previously used crankshafts shall be replaced with the so-called sinus discs, so that the up to now separate operating engines operate within only one drive shaft, so that no additional weight is created by combining the combustion and steam processes, resulting in additional power. Up to here, the heat of the exhaust and the surface of the machines are reused for the processing of steam in the second cylinder. The result is more usable energy and less burned fuel. To reduce the CO2 exhaust, and optimizations of the system can be realized by the combination combustion-steam power, where the hot exhaust are the driving heat source for the steam production of the steam engine. For the optimization of both different heat cycles, adaptations to their physical characteristics are needed throughout the different stroke speeds of the piston that cause the explosion. In relation, the steam piston will operate at half the speed. This is obtained by 2 integrated sinus discs in one. And to make the ratio of physical volume even again, there will be 2 steam pistons for every combustion piston. Both steam pistons still look the same at this point. This will, however, change to result in further increase in efficiency. First of all, we're going to make a symmetrical system out of the up to now asymmetrical system by duplicating the system into 2 separate ones. Then we will join the 2 independent asymmetrical engines into one combined symmetrical system, which of course will be put in a casing to prevent unwanted and uncontrolled heat losses giving out into the atmosphere. Now we take these 2 independent engines to combine them into one, to have a symmetric movement, which results in a more gentle, meaning vibration-free movement. At this point, the integration of the 2 systems with one another has not been illustrated. The integration takes place inside the cylinder and pistons so that they are not beside each other anymore, but they are two in one. With this different design, we are now able to use the whole motor as if it would be the center of the sphere, which is optimal for keeping pressures and temperatures at the optimal condition for an efficient combustion process. In the non-integrated view, any cylinder only operates with one piston. The integrated version operates with 3 cylinders and 4 pistons. We name this new principle of piston arrangements pistons inside pistons. We use a cut image where you can see the movements of the different pistons inside each other. They have different speeds due to the different movements of their sinus discs. The different levels of temperature illustrated are based on an explosion process of Otto engines, whereas the principle can easily be adapted to a diesel alternative. To generate electricity, we can simply connect an off-the-shelf electric generator with the Reinhardt turbine, and use the generated electric energy for transport, agriculture, and any other thinkable applications.